Hello everyone. This program is based on the stack data structure which follows the last in first out principle. It uses stack to represent rods holding colored disks and allows various operations like pushing, popping, moving, sorting and counting disks. The program is organized using two classes for better structure and understanding. The first class stack defines all the basic functions and operations related to stack management. The second class main uses a switch case structure to call different functions based on the user's choice, making the program interactive and easy to use.
So we are going to do stack stimulation as the first case, and when we enter the choice is 1, we can see from which rod to which rod the disk has to be moved. When we give our choice from the second rod to the first rod, we can see the disk would be have moved from the second rod to first rod, and we can see that the statement has displayed as moved disk green from one rod to another. We should have already pushed the disks to the rod at the zeroth case we have already mentioned.
I'm going to explain the Tower of Hanoi concept. Here, I have three rods: source, auxiliary, and destination. First, I place the green disk on the source rod, and then I place the red disk on top of it. Now, the source rod has red over green, while the other two rods are empty. Next, I move the red disk from the source to the auxiliary rod. Then I move the green disk from the source to the destination rod. Finally, I move the red disk from the auxiliary to the destination rod. At the end, the source and auxiliary rods are empty and the destination rod has red on top of green, which is the same order as in the beginning. This completes the Cravara-Fanai operation.
Now we will sort the disk by color. First I'm adding color to the rod. In the first rod I'm adding blue. Again in the first rod I'm adding mm, green color. Again in the first rod I'm adding red color. Since we have added error handling in this program, when we give a color apart from red, blue, green, it will notify us. So I'm adding yellow. When we sort the, it will show red, blue, green, and apart from the three color, it will show to us.
In this program, color counting method analyzes the distribution of disk of different colors across all rods. When the user selects option 4 from the menu, the program checks every rod one by one. Each rod contains disk stored in stack and the method counts how many red, green and blue disks are present in total. It also tracks which rod has the maximum number of unique colors, meaning the rod that contains the most color variety. Finally, the program displays the total count of each color and identifies the rod with the highest diversity. So, this method helps in understanding the overall color distribution and finding which rod has the balanced mix of disc.
In this program, the queue simulation method models a turn based process of adding disk to rods. Similar to players taking turns in a queue, first the user is asked to enter how many turns they want. Then, for each turn, the program decides which rod will receive the disk using the formula 1 mod rods dot length. This means it cycles to the rod one by one. For example, turn 1 goes to rod 1, turn 2 goes to rod 2, turn 3 to rod 3, then back to rod 1 again, and so on. On each turn, the user enters a disk color which is pushed onto corresponding rod stack. After all turns are completed, the program displays the final configuration of all rods, showing how disks have been distributed in round robin fashion, just like serving people in a queue in order. So, this method simulates fair sequential disk placement among rods, demonstrating both stack and queue behavior together.
When the user selects option 7, that is pattern formation, and inputs the pattern length as 3, followed by the colors red, pink, and red. The program stores this as the target pattern red, pink, red. It then checks the selected rod, that is rod 1, to check if it's in the top 3 disks match this pattern in the same order. The comparison starts from the top of the rod and continues downwards. Since the topmost three discs on R1 are already arranged as red, pink, and red, the program finds that the pattern exactly matches the target sequence. Therefore, it displays the output pattern already formed, indicating that no further moves are needed to achieve the desired arrangement.
In this program, we implement the concept of stacks using the stack class in Java to represent three rods A, B, and C. The user inputs the number of disks on each rod and specifies a maximum height limit denoted as K. The program then traverses all the rods to identify which one has the greatest stack height by comparing their sizes. It displays the rod with the maximum number of disks and also checks for an overflow condition if the height exceeds the given limit K. So this code snippet demonstrates the practical use of arrays of stack objects, iterations, conditional checking, and user input handling in Java.